Hello and welcome back to the MongoDB Twitch channel. This is our, I think, second stream this week, but this is an absolute very special episode because this is Lauren Schaefer on the stream. This is her first ever Twitch stream of all time, so this is going to be a great stream. But before we get into the material of what Lauren's going to cover, I want to go over some logistical stuff. So we are live, so the live stream. Ask us questions in the chat. I'm going to be rocking the MongoDB handle today, so that's me, Nick Raboy. If there's any kind of audio or video issues, please drop them in the chat. It's a little difficult for me to kind of detect them myself, but if you notice something weird, just let me know and I'll try to fix it. As far as, do you have any plugs, Lauren, or do you want to introduce yourself since this may be your first exposure to people?
For sure. Well, first, I want to thank Nick for dragging me live, kicking and screaming on Twitch.
Took about 8 months, right?
Yeah, this will be an experience. It'll be interesting to see how it goes. But yeah, hi everybody. I am Lauren Schaefer. I'm coming to you from Pennsylvania, which is on the east coast of the U.S. I am a developer advocate here at MongoDB. Been here for almost 2 years. And I would love to plug some stuff. So you can find me on Twitter and TikTok. My handle is Lauren_Schaefer. Kind of a mess on TikTok, but having a lot of fun doing it. So I'd love to connect with you on there. And yeah, I guess that's all I have to plug right now.
Awesome. Well, if you think of anything later, we could always come back to it.
Cool.
What are we doing today, Lauren?
We are talking about schema, design, anti-patterns. Are you pumped?
Yeah, sounds like such a treat.
It is. It is a treat. Nick, are you familiar with this book, the Design Patterns book, Gang of Four?
I'd be lying to you if I told you I read a book in the past 20 years, so no.
Okay. No. Okay. Well, hopefully some of you out there on the Twitch stream are familiar with the Gang of Four book. It's a classic. Or perhaps you're familiar with this one. It's a little hipper. It's called Head First Design Patterns. Similar patterns, just presented in a trendier format, perhaps. So today we're going to talk about design patterns and why do we love design patterns? Well, they give us best practices and a common language as we architect applications. So when we're modeling data to be stored in a MongoDB database, we talk about schema design patterns. And I know Sherry plugged these a bit last week on her stream. But these schema design patterns help developers be successful as they plan and iterate on their schema designs. But here's the thing. Sometimes developers, we get super excited, we jump right into building our apps without thinking about schema design best practices. And without even realizing it, we've coded ourselves into a big mess. So let's see. There we go. I'm guilty of this. Sometimes I get so focused on creating the MVP that I don't think about the bigger picture, right? I don't worry about what's going to happen as my app evolves, requirements change, my database needs to scale. I just care about doing the minimum work required to get something working.
Awesome.
So that's, yeah. So in MongoDB, we've got 6 schema design anti-patterns. And our goal is for you to learn about them and prevent them.
Oh, sorry.
So as you're rapidly...
I wasn't sharing your screen prior. I am sharing your screen now. I know.
Everybody missed my GIF.
What is the GIF? I put it on your screen now.
We have to go back. Okay.
Go back. All right.
Yeah. You don't want to code yourself into a big mess. Okay.
Yo, Adrian says I'm terrible. We're aware of this already, Adrian.
People would have been very sad if they would have missed that amazing GIF. So, okay. Yeah. All right, where were we, Nick? Let's see.
You were showing us your screen now. Yeah, the 6 design patterns. The 6 anti-design patterns.
Yeah, anti-patterns. That's right. Yeah. So sometimes you'll be going down the wrong path and you may not even realize it. And so that's why the MongoDB Atlas team recently added a new feature that will help you identify anti-patterns in your database for you. Now, for those of you who have been on the stream, hopefully you've heard people talk about Atlas, but just in case, MongoDB Atlas is a fully managed database as a service. I like to use it because it has a generous free tier, and also because I don't really like managing database servers myself. I don't know, Nick, what about you? Do you like managing database servers?
No, absolutely not. That is exhausting and not the highlight of anyone's day, probably.
Yeah, okay, that makes me feel better because I felt like at a database company, like we should really be into that, but I just have no interest. I just want to use my database.
Yes, exactly.
So I'm glad that we have Atlas. So there's this new feature in Atlas that helps you identify schema anti-patterns in your database. I don't know, Nick, have you had a chance to play with this at all? Have you seen this schema anti-patterns tab?
No, I actually have not. So it must be new, right?
Yeah, it's brand new, and it's pretty handy because it'll go in, it'll look at your database, inspect your collections, and say, hey, you've made a mistake, you've got an anti-pattern in your database. So here it's telling me that I'm using case-insensitive indexes, which is not great. So it's letting me know, hey, you've hit an anti-pattern, you should probably go fix it. So today I want to help you understand what the anti-patterns are so that if you see these in your database, you get these warnings, you will know what they mean, and also hopefully help you prevent them in the first place.
Wait, so hold on. I'm looking at your screen here. So case-insensitive indexes. Yeah. So are you implying that we should do all lowercase or all uppercase, but don't mix them, or did I miss it?
So we will go into detail in a bit, but basically you can get yourself into trouble here if you are expecting a case-insensitive query and you don't actually have an indexed case-insensitive index to back it up. And so you'll only get case-sensitive results.
Got it.
Did you follow? That was very wordy. I don't know. Did you follow that?
I did.
Okay. Cool. All right, so today, perhaps, depending on how things go, we've got 6 schema design anti-patterns that we will talk about. So massive arrays, massive number of collections, unnecessary indexes, bloated documents, those case-insensitive queries we were just talking about, and separating data that is accessed together. All right, so Nick, what do you think? Are we ready for the first anti-pattern?
In the chat, yeah, I am. Let's do it.
Let's do it.
I hear my clickety keyboard, right? In the background.
I do.
Doing a lot of hacking over here.
All right, so you're not actively listening to what I'm saying?
No, I am.
Okay. It's kind of rude, but all right.
Oh my gosh, it feels like I'm streaming with Karen and Adrian again over here, giving me a hard time.
Well, you deserve it. You dragged me on here.
Yeah.
So
let's do it. Let's look at this first.
Let's do it. Yeah, so one of the rules of thumb when modeling data in MongoDB is data that is accessed together should be stored together. So if you'll be frequently retrieving or updating data together frequently, you should probably store it together. So you can do it in a couple ways. You could embed related information in subdocuments or arrays. Now, sometimes developers take this too far and embed massive amounts of information in a single unbounded array. And that's where we see the massive arrays anti-pattern. So there are 2 big problems we run into when people start creating massive arrays. Nick, do you have any guesses on what those could be?
The documents get ginormous.
Yeah. Yep. Exactly. So if you get a big array, there's a chance you could start bumping up against that 16 megabyte document size limit, which we don't want to do. Any other guesses?
Performance, maybe. It's a little hard to index them.
Totally. So index performance on arrays decreases as array size increases. And now we want our index performance to be excellent so that our queries will be blazing fast. All right, so let's take a look at an example from the greatest TV show ever created, Parks and Recreation. Let's say we want to store information about government employees like these beautiful people from Parks and Rec and the buildings where they work. So let's explore some different ways we could model this data. So let's begin by considering embedding information about the employees inside of the building documents. So here we can see a document for City Hall. And inside of that document, we have an array named employees that contains a subdocument for Leslie and a subdocument for Ron. Now the employees array is unbounded. So as we begin storing information about all of the employees who work in City Hall, the employees array is going to become massive, potentially sending us over that 16 megabyte document size limit that Nick mentioned earlier. Now additionally, if we create an index on the employees array, the performance of that index will decrease as we add more and more employees. So this is an example of the massive arrays anti-pattern. There are a couple different ways that we could fix this. Nick, do you have any suggestions?
One way that I usually do it is instead of having the employees inside of the building document, I might have the building document inside of the employee document. Does that make sense?
Yeah, so flip the model a bit. I think this is what you're getting at. So let's take a look at an example of that. So here we've got a document for Leslie and a document for Ron. And we can see we're repeating the information about City Hall in the document for each City Hall employee. Now, if we're frequently displaying information about an employee and they're building in our application together, this model probably makes sense. Nick, do you think there are any disadvantages to this approach?
Maybe. I don't know.
There is.
I've just noticed some of the naming inside of your fields, and I got a little kick out of it. Leslie Yep and Ron Swan daughter. I just noticed that.
I'm just trying to keep myself out of trouble.
Yeah.
Yeah. Jason makes fun of me for my husband makes fun of me for these names, and he's like, I can't believe that's what you came up with. And
so we've got a
myself out of trouble
in the chat saying I think that they're answering this question. So NoSQL Know-How says data duplication is a problem.
Exactly. Yes. So let's talk about data duplication. When people talk about data duplication, one of the issues they talk about is storage cost. Now, storage is relatively information about City Hall. We're going to have to update every single document for an employee who works there. So that could be problematic. Now, if we take a look at the information we're currently storing about the buildings, updates are likely to be very infrequent. So this approach could be a good one.
Awesome.
All right, so there's one option. Nick, do you have any other ideas how we could remodel this data?
Let's leave it to the chat. I don't. Sorry, I'm drawing a blank here today. I'm having one of those days.
That's fine. I'm just gonna keep putting you on the spot since
That's fine. I love it. That's what people do.
Put me in this position. Any ideas from the chat?
I'm watching the chat. Nothing came through. Should we be doing like a referral approach between these documents at all? Is that
so like creating a manual reference between them?
Yes.
Is that what you're? Yeah. Okay.
Yeah, and we also got that inside.
I can't tell if that was a real yes. Cool.
Just store the ID of the building in the employees and make a join query. So that's what Wire Enix, I don't know how to say that name, but I'm going to assume that I got it right, said.
I love it. It's like you were looking right at my slides, Wire Enix, and knew exactly where I was going. So thank you for that. So yeah, we can create a manual reference between them. We could keep them separate. So let's take a look at those documents. So here we are creating that manual reference between the employees building underscore ID, which in this case is City Hall, and the buildings underscore ID, which as you can see is also City Hall. So here we've completely separated our data. We've eliminated massive arrays, and we have no data duplication. All right, Nick, what do you think? Is there a drawback you think to this approach?
Chat. So we're saying, can you use the employee IDs instead of all of the employee data? I think that's what we just did, right, Lauren? This is what Michael Cal says.
Can you ask? Can you use the employee's ID? What was the question?
Yeah, I don't know if this is a question or a statement, but it's can you use the employee IDs instead of all the employee data? And that's what we're doing right here, right?
We are joining on the building ID. So I wonder if they're talking about back here.
There was a delay.
I'm guessing that they're saying back here when we were looking at the buildings document, so instead of storing all of their building information, we could store a reference to the employee document here. Yeah. And that would be an option. So basically flipping, I'm getting what they're saying now, flipping it. So here we would have the building ID. Gotcha. Yes, that would be an approach. We would still have a very long array, though, of employees that we'd have to deal with. Consider if that's worth the trade-off. Yes, good question.
And what was the question you had asked me? Because I was looking at the chat when you had asked it. So let's try again.
Oh, let's try again. What's the drawback to this approach of creating this manual reference between the employees and the buildings?
Then you have to maintain the data. It'll change how you do your queries for one. And
that's really the big one.
That's the big one. Was there a second one?
That's the big one. Yeah. So we want to talk about if we want to get this information together, we're going to have to use $lookup. We're going to have to join those documents together. And $lookup is a stage available as part of the aggregation pipeline. So let's walk through what $lookup is, just for people who are not familiar with it. So what you can do is you create an aggregation on a particular collection. So in this case, we're going to aggregate on the buildings collection. And an aggregation pipeline can have multiple stages. In this case, we're going to just create one stage, and that's going to be $lookup. But again, you could have lots of stages here. And $lookup requires you to input 4 fields. I think they're all required and not optional. Not 100% on that. So we're going to say we want to look up documents from the employees collection. And the field we want to join on locally is the _ID field. And the field we want to join on in the employees document is building _ID. And then we're going to store those employee documents in an array called employees. So after doing all of this, this is a document that would be returned from that aggregation. So as you can see, we've got a document with our City Hall information up at the top, and then an array of employees. So you can see our subdocuments for Leslie and a subdocument for Ron. So $lookup can be pretty handy when you need to combine information from more than one collection. But do keep in mind that $lookup operations can be expensive, so it's important to consider how often you'll need to perform $lookup if you choose that option. And I know Sherry touched on this last week, but I want to kind of emphasize again why $lookups are more expensive. And it's very similar to what you would see in a relational database. So when you need to go to a relational database, go get a single row, get out, it's very fast. If you're using a relational database and you need to join information from different tables, depending on how much data is in those tables, it can be a very slow and expensive operation. Same principle here, right? If you can go and get a single document out of your database, it's going to be very fast. If you have to join information from more than one collection and get it, it's going to be a little bit slower. So $lookup, great for rare queries, great for analytical queries that can run overnight or slower, whatever you want to do there. You probably don't want $lookup in your everyday, really frequent queries.
Got it. We have a statement coming in from NoSQL Know-How in the chat. If you use the ID with something like the application can actually piece together instead of a random number. So you can make a separate item with, say, for example, employee : ID object and a employee : ID : building object. When you want the building info, you just follow that convention, basically. I know it was a little wordy for me to read it to you in the chat. I don't know if you're looking at the chat or not. But it looks like it has to do with key design.
Cool.
ID design
Okay.
could help.
Very cool. Well, thank you for sharing that.
That was it.
Were there any questions on dollar lookup before we moved on?
I see no questions as of yet on dollar lookup, but I'll stop you if there are. And I
Cool.
noticed just from a logistical reason, I've seen my network spike. If the quality is like not that great periodically, don't worry. I'm recording it locally as well, so the version I upload to YouTube on demand will be much higher quality. That's all.
Love it. Thank you, Nick.
Yep.
All right, so we've discussed a couple different options. I want to discuss one more option, and that is the extended reference pattern. So this pattern is handy if you find yourselves frequently using dollar lookup. So the extended reference pattern, it's a mixture of the previous two approaches where we duplicate some, but not all, of the data in the two collections. So we only duplicate the data that is frequently accessed together. So let's say our application has a user profile page that displays information about the user, as well as the name of the building and the state where they work. So we could embed some of the building information, like the name and state fields, in the employee documents, and then leave the complete building information in separate documents. So let's take a look at that. So here you can see we've added the building's name and state in each of the employee documents. And then the building documents contain the complete building information, so we can query for that as needed. All right, Nick, what do you think? What do you like about this? What do you not like about this?
Wait, so let me understand this correctly. So we're storing part of the information inside of the employee document, and then the rest of that information elsewhere.
Yep.
What key are we using if we wanted to go get that extra information? Does it matter?
We could store if we wanted to. Yeah, we could store
Yeah.
the building ID here if we wanted to be able to reference it later, or if we know it's going to be static or we're going to be updating it at the same time as the employee, we don't necessarily have to store the ID.
Now, so something that's coming to my mind, and I don't know if this is a big deal or not, but if we're storing any information and then we're storing like a kind of root of all information document, like that separate buildings document, aren't we going to worry about data becoming incorrect or invalid?
Yeah. So that is the tricky part when you start duplicating information. And so it's very important that your application handles that and keeps track of it for you. So you have to be kind of proactive as you're developing your application and making sure you aren't screwing that up.
Yeah. Was that what you were looking for, or was there something else?
Yeah. So the nice thing about this is that if we, for our user profile page, we've got the information we need, so we can come in and get a single document. And then if we need, a separate page just for building information, we've got that as well. So it really all depends on your use case and how you're going to use the data.
Sweet.
Yeah. All right. So we're going to summarize. We made it through one. So do store information together that you'll be frequently querying together. Remember, data that is accessed together should be stored together. Don't store information in massive, unbounded arrays that will continue to grow over time. So it's always true with schema design patterns and anti-patterns. Carefully consider your use case in order to determine what schema design is best for you. All right, I think we made it through one, but before we move on, I'm going to pause. Are there any questions, Nick?
Yeah. What kind of Mountain Dew are you drinking today?
Okay, so I knew you would make fun of me. I am a big Mountain Dew fan. Today I'm drinking Coke Zero.
Oh, gosh.
The quarantine pounds have been piling on, and I had to stop buying Mountain Dew for my house. Yeah. What kind of Mountain Dew are you drinking today?
Got this gamer fuel right here. I'm putting it on the camera there. No, we're not getting any kind of Mountain Dew money out of this. But yeah, that's my Mountain Dew of choice today.
Do you think there's a way we could get sponsored by Mountain Dew? Because I feel like you and I are like Team Mountain Dew on our team.
Yeah, Mountain Dew, if you want to give me some T-shirts, and I'll wear them on the stream.
Yeah, totally.
If they're watching. Anyone knows anyone from, is it the Pepsi Cola company? Have them talk to us. I don't know.
Yeah. Yeah, that would be pretty sweet, actually. Yeah. I feel like there's a lot of hate for sodas, but I love Mountain Dew. It's
Oh
the
yeah,
best.
but not Diet Mountain Dew. No, stay away
No,
from that.
but Mountain Dew Zero is really delicious. Yeah. Okay. I'm sure
Awesome.
everyone enjoyed that
I
diversion.
know, because we're
Okay.
probably the only ones here that like Mountain Dew, right?
Yes. Yes. It's okay.
Yes, I think
All
that is
right.
the what they chose to water the crops in that movie. Did you see the movie Idiocracy before?
No.
Where it's a bunch of Saturday Night Live people. I guess they end up in the future, and the future's really, really dumbed down, and they use like Mountain Dew to water crops, and
Wow.
an interesting movie.
I'm intrigued by the implications of that. Like, would your crops taste sweeter and have higher energy?
Sure, I don't know. I think there's something
Okay.
going on with the crops. It's been a while since I've seen that movie. It's a good one, though.
Okay. All right. Okay, anti-patterns?
Yes, let's do it.
Okay. All right, let's talk about a massive number of collections. So, turns out massive arrays, not good. Massive number of collections, also not good. So, if storage is relatively cheap, who cares how many collections you have? Turns out they're not good. So, Nick, I'm going to put you on the spot again. What do you think? What could be some problems you run into if you have a massive number of collections?
Um, there any kind of performance considerations around that?
There sure are.
Yeah.
That's the answer to everything. It's performance. Yes. Okay, so empty and unused indexes drain resources. All right, so why am I talking about indexes? Well, every collection in MongoDB automatically has an index on the underscore ID field. Now, while the size of this index is pretty small for empty or small collections, thousands of empty or unused indexes can begin to drain resources. Now, collections will typically have a few more indexes to support efficient queries, and all of those indexes will eventually add up. Another performance issue. So, Wired Tiger is MongoDB's default storage engine. Now, I tend to just kind of gloss over the Wired Tiger storage details. I don't know. Nick, are you really into like storage details?
I am not personally. I can imagine that there are plenty of people who would be very interested in knowing how their data is stored, but the way I see that my data is being stored, that's great. Let me just write some code, right? Let me just use it.
That is my view. So I had to like really learn this stuff in order to be able to talk about it because this is not my area of expertise. So we're going to give it to you from a high level. So Wired Tiger performance will decrease with an excessive number of collections and indexes. So why is that? Well, Wired Tiger stores a file for each collection and a file for each index. Now, Wired Tiger will open all of the files upon startup, so performance will decrease when an excessive number of collections and indexes exist. All right, let's take an example. Now, this is Leslie and Ron. Leslie's here on the left, and she is the main character in Parks and Rec. And you know what? Let's digress for a minute. I am a bit of a Leslie. Nick, do you identify with a particular character on Parks and Rec?
Maybe Ben. I don't know.
You're a Ben. I was
Probably.
thinking about it. You're probably a Ben, and I was also thinking you're a bit of a Mark Brandanowitz.
Yeah, all right.
Pretty like chill, calm. Yeah. So maybe we should start calling you Mark Brandanowitz.
Yeah.
Anyway, okay. So this is Leslie. She's incredibly passionate about maintaining the park she oversees. And at one point, she takes it upon herself to remove the trash in the Pawnee River. Now, let's say that she wanted to keep a minute-by-minute record of the water level and temperature of 3 rivers, the Pawnee River, the Eagleton River, and the Wampapoke River. And she wants to be able to store that data to look for trends. So she could send her coworker Jerry to put 30 sensors in each river and then begin storing the sensor data in a MongoDB database. So let me show you one way that she could have stored this data. So I'm jumping over to Atlas. So here you can see we've got a database called River Stats, and then we have a collection for every day of the year.
That seems
and then inside
awful.
It seems awful. Okay, you've already picked up. This is the anti-pattern.
Yeah.
So
and now I'm actually
each
seeing
collection,
it on paper now. It's one thing to talk about it. It's another thing to see it, and that does not look good.
No, it's not good. So if inside of each collection she had a document for one sensor for, let's see, I think this is every minute. Let me check what I did here. Yeah, so each collection would contain documents that store information about one reading for one sensor.
So I feel like I have to ask, do people actually store their collections like this? I mean, maybe I'm ragging on people too hard, but is this like a real thing?
Yeah, well, it gets tricky when you start looking at IoT data because you've got so much data, and you're going to kind of figure out, how am I going to store this? And if you think about, like, you might have, if you were in a relational world, you might have a row for every sensor. So yeah, you could end up with something like this. All right. I did not go peeking in people's databases to see how they stored their data, though. So,
Got it.
All right, let's take a look at her indexes. She knows she wants to be able to easily query on the river and sensor fields. So she's going to create an index on those fields for every collection. And it seems like my internet hates that I'm streaming on Twitch. Maybe it senses my nervousness here. Okay, it caught up. So we've got an index on sensor, an index on river, and then the default index on _ID. Now, because she has so many collections, she's got, 3 indexes for every collection. So let's take a look at her stats for this particular database. Now, I've got information in here for every minute of 2019 in this database.
Yeah.
So her database is 5.2 gigabytes, her index size is 1.07 gigabyte, and she's got 365 collections.
Oof.
So each day she creates a new collection and 2 indexes. Now, as Leslie continues to collect data and her number of collections grows, the performance of her database is going to decline. Also, when she wants to look for trends across weeks and months, she'll have a difficult time doing so since her data is spread across multiple collections. So let's talk about how she could restructure her data. I'm scared to ask Nick. Do you have suggestions on how we could restructure this data?
Yeah, so I mean, if this was me dumping tons and tons of IoT data in there, I would create like a snapshot document, and rather than just storing dailies inside of collections, I might start offloading it into Data Lake or Online Archive if I really wanted to offload it or organize it that way. But I mean, I don't know. I don't know. I feel like a snapshot would just get the job done. Any kind of IoT operation could just get dumped in the same collection.
Yeah. So I'm not going to get into, you're presenting very good arguments. I was like, oh, what's Nick going to say? So yes, talking about Data Lake is great. Talking about Online Archive is great. That's not the direction I went, though.
All right.
So we went with a single collection. And here you can see we've got readings for a sensor, and it's readings for a full hour in each document. So we've bucketed the information by the hour. So here you can see this is like hour 0. Let me scroll down.
What's the size of those documents, each of those documents?
That is a good question. Is there an easy way to pull that up?
I don't know. I was hoping you knew. You could probably figure it out somehow. I don't know off the top of my head. I'd have to look it up.
Yeah. I wonder if we can look at...
They don't look particularly large. I mean, how many documents did we have in per collection again? We could probably do an estimation. Many. Just many.
We've got many.
All right. It's all good.
Okay. Let's see. I wonder if it'll tell us if I go to the database stats.
Well,
Yeah, here we go.
Sherry C says the collection size was 3 gigabytes. So if the collection was for a single day and you're doing it per hour, you're probably looking at I would like to assume that it's fairly large documents then that you're looking at if you do it
So
that
they're
way.
about it says here 4 kilobytes document
Really?
average.
Oh,
Yeah.
all right. You're looking at the new one, where it's
the
an
new
array.
one.
All right. I thought Sherry C was
Yeah.
referencing the other collection where it was collections based by date.
Yeah.
I don't know what the documents were for that. That makes
We
sense.
can
That's
go-
better.
We can go back and look. Why not?
Yeah, what was one of those collections in size? You're looking at the entire as a whole.
What is? I think the document average is
Document size is
isn't. My guess is this would be the size of the document.
yeah. No, it's yeah, maybe.
Okay. We're nailing it. I'm sure
Sherry's-
Sherry's like
Sherry's
screaming at
walking
us through the
it.
screen.
Yeah, she is. She's walking us through in the chat because we don't the
Okay.
two of us don't know what we're talking about. She says that if we click on the collection name, it's under the collection name, the size of the collection. Yeah, we saw that.
There we go.
It's all good.
Okay.
We're
you,
digging.
Sherry.
We're going down a rabbit hole that we probably shouldn't go down.
Thank you, Sherry. Okay. So here's where we ended up after that. So her new database is 3.07 gigabytes. And, I'm in the wrong spot. Let's go to the database stats.
We obviously spend
Her
most of
database-
our time writing code, right? And looking at this stuff.
Performance, okay. Yeah. So database size is 3.07 gigabytes, index size is 27.45 megabytes, and she's down to 1 collection.
Sure.
So let's take a look. I'm going to jump back to the slides so we can look at it side by side, because to me that's a little easier. So we can see we've got a massive reduction in the index size, right? We went from 1 gigabyte down to 27 megabytes, which is pretty nice. And we now have a single collection with just 3 indexes. So with this new schema, we can more easily look for trends in the data because it's stored in a single collection. And let's see. So Leslie was able to remove unnecessary collections by changing how she stored her data. Did you just break something, Nick?
No, my soda just exploded. Yeah.
Oh my gosh, I wish I could see you. Did it go all over
Yeah.
your face? Like, was it an exciting explosion?
No, I think it ended up all over my keyboard, but it was not a very good explosion. But I'll clean that up
Oh.
later.
Maybe
Mountain
somebody
Dew.
can turn that
Game
into a
fuel.
GIF.
Yeah.
Now we really need Mountain Dew to be a sponsor. All right. Okay, are you good, Nick? Or do you need to go get a towel?
No, I'm good. I'll live.
Okay. All right. So, okay, as I was saying, so we were able to remove unnecessary collections by changing how we stored our data. But sometimes you're not going to immediately know what collections are necessary. So you'll have to do some investigating yourself. Put on your Sherlock Traeger hat. So how do you know if you should drop a collection? All right, Nick, do you have any ideas on this one? How do you know if you should drop a collection?
Can you I think there's a schema analyzer in Compass, right? That'll let you see the activity of, or is that just for indexes?
I know it works for indexes. There is a schema analyzer that'll help you see what's in the collection.
Yeah.
So
Is there a way to check
don't know.
activity on a collection? I mean, where are you going with this? Oh, if it's
that's a
empty,
good
all right,
question.
obviously.
That is not
right?
that's not where I was going. But I bet Sherry can set us straight there. Sherry's like, I can't believe you guys don't know this. Okay. I don't know if you
Saying
can
the
check
database
activity
goes
on a
faster when
collection.
you drop all the data.
Exactly. So yeah, this is an obvious easy one. If it's empty, you can drop it, right? Okay. Also, this one I would not have thought of on my own. So if you find a collection whose size is made up mostly of indexes, you can probably move that data into another collection and drop the original. So let's talk about what tools you can use to do your investigating. So we can use Atlas. Let's see. Just like we did, we came in, we checked out our database size, our index size, our collections. Another tool we can use is Compass, which you just brought up. So let's take a look at that, and we'll look to see. I want my other compass. Here we go.
Wait, you have several instances of it open at the same time? I didn't know you could do that. Yeah.
Oh, yeah.
All right,
because
I learned something new
I got more
today.
than one cluster open. There you go. That's all you've learned from the anti-patterns is you can have
I learned a lot.
more than one cluster. Come on.
I don't know a whole lot.
Okay.
You've educated me on a lot today.
Thank you.
I
That
probably
makes me
should
feel
have
much
already
better.
known this stuff, but I do not. I did not.
Okay, great. So I'm here in Compass, which is MongoDB's GUI. It's like a desktop tool, and you can use it regardless of if your database is hosted on Atlas or if it's hosted locally on your machine or on your server, wherever. So Compass is a great tool to use. And here you can see the same stuff we saw in Atlas. So like the number of documents, average document size, total document size, number of indexes, total index size. You can go into a collection and check out the documents as well. So that can be helpful. And I know that some of you will always prefer to work in the command line over a GUI. So let's talk about that. I'm not a command line person, but I know that hardcore coders are. So let's take a look at that.
So I actually prefer to work in the Visual Studio Code extension, of all things, right? Have you tried that one?
I know that I should, but I have not tried it yet. I keep hearing great things about it.
Finally, I've done something that Lauren's unfamiliar with.
Don't tell Joe, okay? All right.
Yeah.
Yeah, and I heard the shell is now inside Compass too, which I haven't tried either. So all the tools are like converging and becoming more and more helpful, which is nice. So can you see? Let's see. You told me that the bottom of my screen was cut off a bit. So, all right. So I logged into my database, so I can run things like db.stats, and it's going to tell me things like my index size. What else is helpful? Data size. So same stuff we could see in Atlas and Compass. If we want to see the collections, we can run db.getCollectionNames. And there we can see all 365 collections. If I want to get stats on one of those collections, I could say db.getCollection with the name of the collection. Let's do December 31st.
When somebody's got a database that looks like this, what do they typically do? Just drop the collections after a year and start fresh, or do they just keep piling them on?
That's a good question. I mean, it depends on your data.
This is a real scenario,
right?
Yeah.
Well, I admit I did make up this example, so
All right.
I don't know.
But there could be people
It's a good
doing
question.
this, right? I'm just
There
curious.
could be, yeah. Yeah, there are people definitely doing IoT stuff like this. So it depends if you still need it. But they're probably going to have to bucket it like we saw because this is out of control.
Oh, TBD gamer says they'd probably use database underscore 2019, database underscore 2020 in addition to the collection names. That could work.
Yep. But probably you want to bucket it. Yeah. Okay, so I just ran db.getCollection.stats, and here you get a ton of stat information about the collection. So you can come in and just kind of explore. So you can use any of those tools, Atlas, Compass, or the shell, or the VS Code extension, and you can do your investigating. So jumping back to the slides. Oh, we made it through another pattern. Okay, so let's summarize this massive number of collections anti-pattern. So don't create a massive number of collections, as each collection likely has a few indexes associated with it. An excessive number of collections and their associated indexes can drain resources and impact your database's performance. And do remove empty and unused collections. All right.
We had a question come
other
in.
Questions?
From Michael Cal. How would you do an aggregate report on something like this?
It's a
You
really
probably
good
have
question.
to do a pretty fancy aggregation pipeline, right?
Probably, yeah. I don't know if I could put something together on the spot or not. So
We need
you'd
Karen to
probably,
come back
what
here.
I would
She's
do,
good at this.
yeah, you'd probably want to go into the aggregation pipeline builder in Atlas, which is where I do it all. Ugh, oh, my screen is so big, it's struggling. Everything's zoomed in too far. Okay, I'm going to zoom out just so I can see what's happening.
Still
And
see
you'd
it
come
like
in
that.
and
Still good.
oh, okay. And let's see. We could probably come in and pull like average water level or something across all of these, but I
All right,
am
I don't
not
think we
good
should.
at
I don't
doing
think we
stuff
need to
like
dig
this on
into
the
it that
spot.
much.
Okay.
We need to have a
But,
stream
yeah,
anyways on the aggregation pipeline. So I need to see if we can get some of our pros that are better than me. Maybe you're better than me already. So, but like top notch. Like
Yeah.
Asia, I'm thinking.
Yeah. Asia and Karen. Yeah.
Yeah.
I like these questions in the community. We haven't plugged the community yet. I love when people ask these questions on the community, and then I can like sit and tinker and try and figure out the best aggregation pipeline, which is fun. So if you ever get stuck trying to figure out an aggregation pipeline, you can definitely go on the MongoDB community and ask your question.
Yeah, we're getting another question here from Twyron Enix again. So what you keep referencing to bucket it? What does that mean?
What does that mean? So what we did, let me show the data. So what I did was I created a document, and that document is a bucket for all of the readings for, I believe I bucketed by the hour. So if we come in
This is
and
what you
look-
mean when you say you probably need to bucket it? All right.
So we're combining the readings into buckets. So maybe you want to bucket by the hour or by the day. It's grouping them together so you don't have a whole bunch of individual documents. And I'm going to pull up. So I've kind of hinted at this. We've got schema design patterns, and Daniel Kupal and Ken Alger wrote a fantastic blog series about it. And there are, I think, 12 patterns that they talk about, and one of those is the bucket pattern. So if you want to learn more, come check out this blog post that specifically focuses on the bucket pattern.
Perfect. Thank you. And Shiri is proctoring the chat as well, and she's answering a lot of this simultaneously in parallel with you. So
Love
it's all
it.
good.
Thank you, Sherry. All right. So Nick, how are we on time? Do we want to do another pattern? Do we want to wrap up? How are we doing?
I have emptied my calendar for you today, so you have the full day if you want.
Okay.
It's up to you.
I don't think anybody wants to listen to us for that time, for all day. But wait, let's do at least one more pattern. All right. So let's talk about indexes.
We're getting a message from Stefan. I don't know, very long name. Do another pattern. This is excellent.
Oh, yay! Okay, let's do another pattern. Let's keep going.
And Shiri
So-
says, I want a whole day of Lauren.
Okay. Oh, Sherry. Thank you. All right. So we're talking about unnecessary indexes. But before I go any further, I want to emphasize that indexes are good. Okay. So indexes allow MongoDB to efficiently query data. If a query does not have an index to support it, MongoDB performs a collection scan, meaning that it's going to scan every document in a collection. Now, if you have a whole bunch of documents in your collection, the collection scan can be very slow. So if you frequently execute a query, make sure you have an index to support it. Indexes are good. All right. So now that we have an understanding that indexes are good, you might be wondering, should I create an index on every field just in case I'll need it in the future? Nick, what do you think? Should we create an index on every field?
No, and I totally missed half of what you said because I'm just laughing at somebody in the chat.
Nick, pay attention to me. Okay.
I know, right?
No, this was an easy setup. this is an easy setup. No, we don't want to create an index on every field. Let's talk about why that is. Well, indexes take up space, so each index is at least 8 kilobytes and grows with the number of documents associated with it. So thousands of indexes can begin to drain resources. So we're talking about performance again. Also, we're going to talk about WireTiger again. So indexes can impact storage engines' performance. So remember, WireTiger is MongoDB's default storage engine. And we talked about this a minute ago, but WireTiger will store a file for each collection and a file for each index. And WireTiger is going to open all the files upon startup, so performance will decrease when an excessive number of collections and indexes exist. All right, so indexes can impact write performance. Whenever a document is created, updated, or deleted, any index that is associated with that document must also be updated. These updates to the indexes will negatively impact write performance. So it all comes back down to performance. So in general, this is a real ballpark number, but in general, we recommend limiting each collection to a maximum of 50 indexes. So what you want to do is identify which indexes are truly necessary. All right, so how do we know if an index is necessary? All right, Nick, do you have any ideas on this one? How do we know if an index is necessary or unnecessary?
I think you could analyze that inside of Compass, right? You can see, and I believe it's out right now. There's some index, what is it? Index autopilot in Atlas.
Ooh, I don't know about that. Tell me about that.
Well, maybe I shouldn't talk about it. There's I don't know. I totally forgot if I'm able to talk about it or not. I think it's available, but where it suggests indexes for you based on your usage or based on your query.
Love that. Okay, so
I'll follow up with that.
Okay.
We have a podcast coming out on it, but I don't know the release date yet.
Love it. So you said we can look in Compass. What are you looking for in Compass? What are we checking about the index?
What are we checking?
Yeah, so you said you can go look in Compass to see if the index is necessary. Like, what are we checking? What stats are we checking on the index?
It's a good question. I don't know.
Okay, so we're checking if it's actually being used, right?
Yeah.
So we can go in Compass and see how many times it's being used compared to the other indexes. So if the index is rarely used, it's not used at all, let's dump it. Then there's one other way we know we can dump an index, and that's if it's redundant because another compound index covers it. So let's take a look at an example because it'll hopefully become more clear. All right, so Leslie, back to Parks and Rec, Leslie often looks to other powerful women for inspiration. Now let's say that Leslie wants to inspire others, so she creates a website about her favorite inspirational women. So this is a very ugly website, just to pretend like it's pretty. The website allows users to search by full name, by last name, or by hobby. Now, Leslie rhetorically asks if she's going to make her website awesome, and you know she will, because she's Leslie. So let's take a look at how Leslie modeled her data for this awesome website. Let's see if I'm in the right collection. Okay. So here we are. I'm in a collection called Inspirational Women. And inside of that is a document for each inspirational woman. So here we can see a document for Sally Ride. Now let's take a look at the indexes Leslie created. Scrolling. All right, so here we've got a ton of indexes. It looks like Leslie got very excited. Perhaps she drank some Mountain Dew. Perhaps she was eating Nutrient bars. She got on a sugar high, and she created an index for every field in her collection. All right, so we're looking at, right, all comes back to performance. So let's look at the usage here. We can see this last name one, first name one index is being used a lot. her hobbies one index is being used a lot, and the rest really aren't being used at all. So let's think about why that is. I'm going to jump back to the slide just real quick. Let's see if we can search by full name. So that's that's why our last name one, first name one index is being used. We can search by last name, and that search can also use that same index, that last name one, first name one index. And the hobbies is using the hobbies index. So even though we have this last name one index, it's not really being used because it's a duplicate of this last name one, first name one index. So really what she could do is come in and click drop index for the rest of these. She's got a bunch of unnecessary indexes. So let's take a look. Nick, did you follow that? Any questions on that?
Yeah, I think I followed all of that. Did your screen? Are you still on the Atlas index page? I don't know if your screen froze or not, and I need to refresh it.
Yes, I am.
All right.
So I'm going to flip over to Compass then, so we can take a look in there.
We had a request in the chat from Stefan if your slides were going to be posted somewhere after this.
Yes, that is a good question. I don't know if I don't think they are posted yet, but I will take a moment and I'm going to plug my video series that is coming out. The first video in the series just came out yesterday and covers the first two anti-patterns, I think, and series, and they'll be released one per week for the next 2 weeks. So if you want to check out the MongoDB YouTube page, you will be able to find this information there as well.
Sweet. And
maybe somebody can drop a link for it for me in the chat.
For the YouTube? Yeah, I can do that.
Thank you. All right. So let's take a look in Compass. We can do the very same thing. We can come in and look at our indexes to see what's being used. And Compass shows it a little differently rather than showing like, I think Atlas was over time. Let's see. Let me make sure I'm saying it right. So Atlas shows you usage per minute. That's right. Compass shows you just total usage. So we can see hobbies has been used 232 times, and the last name one, first name one index has been used 484 times. And just like we could in Atlas, we can come in and click a handy button and drop the unused index. So I'm going to jump back to my slides now. There's Leslie again. All right, so let's summarize this anti-pattern. Do create indexes that support frequently run queries. Remember, indexes increase read query performance. So do create indexes. Don't create unnecessary indexes. Unnecessary indexes reduce performance and take up space. An index is unnecessary if it's not frequently used by query, or if it's redundant because another compound index covers it. You can use the Atlas Data Explorer or MongoDB Compass to help you discover how frequently your indexes are being used. When you discover an index is unnecessary, remove it. All right. So, Nick, I'm wondering if this is a good spot to stop. What do you think? Because we're at an hour.
It's totally up to you. We could do a part 2 if you're down for a part 2 in the future.
Yeah, let's do that.
All right, so we're getting a question in the chat from Michael. I believe that's how you say this name. Is it easy to rebuild an index if you decide you actually do need it?
Yes, it is easy to rebuild an index. Let's create an index. They will take time if you have a bunch of data. It does take a little bit of time to create one, but as far as the ease of doing it, it's pretty simple. If I wanted to do something like, these all have indexes on them, but let's do backwards. So we'll create a first name index and a last name index. So we went first name, last name and create it. And yeah, it's already created. So it just depends on how much data you have in your database.
Awesome. Yeah, I mean, we'll let the questions trickle in. Is there...
For sure.
I mean, we plugged the community, so If you have any questions after this stream, sign up for the community. It's community.mongodb.com. It's just a forum board, but we'll see it. We'll see it happen, and we'll engage. It's a great way to follow up with us after the stream. Yeah, Lauren is loading it up on her screen. Pretty familiar forum board. This video will also be on YouTube. Probably not today, but in the near future, I'll upload it to YouTube. What am I missing, Lauren?
Well, so I created a post on our forums about anti-patterns. So if you are thinking about this later in a day or two and you're like, oh, I've got a question, feel free to come in and ask the question on here or start your own topic, whatever you want to do. But we'll definitely be checking back. And then also there's a link in there to my blog series that covers all of the anti-patterns. So you can come in and see each anti-pattern has its own individual blog post. So you can come in. It's the same examples I covered today, all in text form. So you can come through, read about them, and see the examples there as well.
Yeah, I'm trying to dig those up right now on the blog so I can just paste the link in. What was the date on that one?
That
Just searching
one
for 'em.
was
Oh, you know what? We have
back
search
in
on the blog
April.
now.
Yeah.
That makes life easier. All right. What do you recommend? Should I link to the first one? They're all linked up, right?
They're all linked up. So the series table of contents is all the way at the bottom. And then if you're looking for a particular pattern, you can find it down there at the bottom of the post.
All right. I'm copying it, and I am pasting it in the chat. That's one of them. You'll find the rest of them at the bottom.
Love it.
Wait. Oh, I clicked on the wrong one. That was schema design patterns. I need to look for anti-patterns.
Yeah.
How did that happen?
Is that a Daniel and Ken's post, maybe?
Yeah, I didn't even pay attention.
Plug in the wrong thing. No, you should read. Their stuff is really good. You should read it too. But also read my stuff. Thanks.
All right, I got a new link coming in.
Okay, cool.
There we go. New link in the chat. Anything else you want to plug, Lauren?
I think that's... Find me on Twitter and TikTok. I'm Lauren_Schaefer.
Sweet.
I think that's it.
Well, I'm glad that you were on the stream. I'm going to rope you into part 2 for sure. I want to learn about the final 2, so you're on the hook.
All right.
But no, this was a lot of fun. And you stumped me too many times, more times than I feel comfortable with. But it's good. Everyone, thanks for tuning in. Remember to stream with us. We stream pretty much every Friday on some kind of topic, and then we also have a game dev series that we do on Wednesdays. So whatever your jam is, I'm sure that you're gonna find something that's up your alley here. Treat yourself to a stream, right?
Treat yourself. That's right. Excellent reference.
Yes. See you later, everyone.
Bye.